All right, here we go. Now, this is the lesson we started on the other day, and I told you that we were going to revisit it. We didn't revisit it yesterday, but we are revisiting it now. Students will, this is the objective, students will understanding the meaning of the denominator and numerator of a fraction, and will add fractions and mixed numbers. And it says without borrowing or reducing, but I think we will get to that today. All right, there are two numbers in a fraction. You know that, right? You know there are two numbers in a fraction. One on the top and one on the bottom. The number on the bottom is called the denominator. The number on the bottom is called the denominator, and it tells you how many equal parts make up an entire object. And guys, an object doesn't have to be like a rectangle. You know, this classroom could be an object. Okay? Look at the object given here and tell me how many equal parts there are. So how many parts are in this?
6.
There are 6 parts in this. So the denominator of this fraction would be a 6 and would be written with the 6 on the bottom and some other number on the top. So that bottom number, that denominator, always tells you how many equal parts there are. So now let's talk about the top number. The number on the top is called the numerator, and it tells you how many of the parts are selected. The same object is given below. I took this object right down here, but some of the sections are shaded. How many of the sections are shaded?
4.
4 out of the 6 are shaded. So the fraction that tells you both pieces of information, how many objects there are and how many are shaded, is, the fraction that tells you that is 6 equal parts, 4 are selected. So you can't see that. Let me move this up a little bit. You got to let me know when you can't see. All right, so the fraction that tells you both pieces of information, how many objects there are and how many are shaded, is 4 out of 6. 6 equal parts, 4 of them are selected. Let's write some fractions to describe, it says out class, but that's supposed to say our class. My apologies, please correct that spelling. Let's write some fractions to describe our class. Now let's pretend John's here, okay? Let's pretend John is here. Hey, John. The fraction of students that are girls. Now you're all writing in pencil. I want you to write the fraction first. And if it's wrong, we'll just put an X over it and we'll fix it. Right now, everybody, the only way you're going to completely miss this is if you don't put an answer. So I want to see an answer on your paper. Number 1, the fraction of students that are girls. All right, let's see here. Okay. Okay. Right here? Okay. Okay. All right. Only one of y'all got it right. Now, in a fraction, the bottom number tells you the total number of parts. The top number tells you how many are selected. Graham, how many students are there?
6.
5.
Oh.
We're going to pretend John's here. 1, 2, 3, 4, 5. Okay? So the bottom number is going to be a 5. What kind of students did I select?
Girls.
Girls. How many girls are there?
2.
2 girls. So the fraction of students that are girls would be 2 girls out of 5 students. Now I want you to do number 2, the fraction of students that are boys. And remember what those 2 numbers are actually telling you. You might want to put an arrow.
I put like a finger there.
Okay, I think that's a good idea. Yeah, I should have given you more room.
So, you know,
What's your answer? What's your answer? Okay. All right, so yeah, I didn't give y'all enough room, so I'm gonna use my pencil, just draw an arrow over here. The fraction of students that are boys, well, once again, we have 5 students, but the number of boys would be 3 out of 5, okay? Number 3, the fraction of humans that are teachers. The fraction of humans that are teachers. Pretend John is here. All right, what's your answer, Addie? One out of 6. That's right. There are 6 humans. One of them is a teacher. Number 4, the fraction of humans that are students. The fraction of humans that are students. What you think, Graham?
5 out of 5.
Well, you're right that there are 5 students, but how many humans
0
are there?
Out of 5.
6. I'm a human. Okay? So all of us are humans. That would make 6 of us. 5 are students. All right, number 5, the fraction of students that are dogs. What do you think, Hannah? Number 5, the fraction of students that are dogs.
Yep. Okay. 0 out of 5.
0 out of 5 is absolutely correct. We do have 5 students. None of them are dogs. Do not be afraid to use 0 in a fraction. 0 tells you something. There are no dog students in this classroom.
Well, hold on. Let me pull out my dog.
Yeah. Yeah. Didn't bring mine with me, so we have 0 dog students. Okay. Number 6, the fraction of students that are living on a good day. What do you think, Davis?
let's do. So, are we counting humans in this whole thing?
What does it say?
All right, fraction of students that are living 5/5. So
5 out of 5. That's right. There are 5 students. All 5 are living. John's not feeling so great right now, but hopefully he will be back next week feeling great. Okay, so now that you have a better idea of what the numbers in a fraction represent, let's review how to add fractions together. All right, so you feel good about knowing what a fraction is. The 2 numbers tell you different things. The bottom number always tells you how many parts there are in an object. And don't think an object has to be like a candy bar that's divided up or an apple that's divided up. In this example, we used our classroom as the object. Yes, sir?
So we were watching a science video. Remember that, guys? The weather science video with Studio C, and they were. Me, John had something.
And what is it that you want to tell me about it?
So it's kind of a funny family thing, but like what they did was a weatherman would say things that weren't like realistic, and there'd be like hail the size of basketballs and things like this. So I'm wondering, John accidentally got caught up in.
Oh, in a hailstorm with basketballs.
That's not possible.
I love people that have a sense of humor, like a weatherman like that. Okay, so I have given you two diagrams here. Now, it may not look like it, but this rectangle and this rectangle are exactly the same size. Okay, they've been divided up differently, but the two rectangles are the same size. Identical rectangles have been divided into portions. What fraction represents the shaded portion of the first rectangle, Addie?
3. Or
What
1.
fraction represents the shaded portion of the first rectangle? So your answer has to be a what? Your answer has to be a fraction, honey.
Oh, 1 of.
See, the question is what fraction? So what is it?
1 of 3.
1 out of 3. All right, Graham, what fraction represents the shaded portion of the second rectangle?
3 out of 1? Or 1 out of 3? Oh, wait. Sorry.
Okay, point to the rectangle you're looking at. That's the first one, honey. You're doing this.
Oh, okay. 1 out of 6.
Yes, sir. Exactly right. 1 out of 6. So, in the first rectangle, 1 out of 3 are shaded. In the second rectangle, 1 out of 6 are shaded. So both of them have one shaded part. Are these the same size?
Wait, what are you?
No, they're not, are they?
Well, you said
Which one's bigger?
the 1 out of 6.
Really? That one's bigger?
No one's bigger.
Oh, 1 out of 3 is lots bigger than 1 out of 6. When you look at these fractions, you might think because 6 is better than 3 that this fraction's bigger, but it's not, is it? This means the exact same object is divided into 3 parts and you have one of them. Think of your favorite candy bar. Think of a Reese cup divided into 3 parts. You're going to get a couple of bites, aren't you?
Couple.
If that same Reese cup is divided into 6 parts, are you going to get as much? You're not. So these are not the same size. Well, if they aren't the same size, then they can't be added together. That's why you cannot add unlike fractions together. Today you'll learn how to take 2 fractions with different denominators and make fractions with like denominators that can be added and subtracted. You'll need to learn and memorize this first part of the fraction wrap to help you remember this rule. Now, this is the same fraction wrap that we did the other day. So, adding and subtracting is plain to see when you match the denominators perfectly. Adding and subtracting is plain to see when you match the denominators perfectly. Hannah.
Adding and subtracting is plain to see when you match the denominator perfectly.
That's good. Addie.
Adding and subtracting is plain to see when you match the denominators perfectly.
Good. Davis.
Adding and subtracting is plain to see when you match the denominators perfectly.
Absolutely. And Mr. Davis.
I said that.
I'm sorry. Mr. Graham.
Adding and subtracting is plain to see when you match the denominators perfectly.
Okay. Say it a little bit slower because when you are saying this to you, I want you to hear what you're saying. So don't race through it. Put a little jive with it. Let's hear the beat. Come on. Come on, Graham.
Adding and subtracting is plain to see when you match the denominators perfectly.
All right, there we go. Adding and subtracting is plain to see when you match the denominators perfectly. Now, it's a little bit goofy. Do you see what it tells you to do? Match the denominators. It tells you what to do. but only when you're adding and subtracting, because when we hit multiplying and dividing, the rules change. So when you're adding and subtracting fractions, you've got to match the denominators. So this little wrap helps you remember the rule that goes with adding and subtracting. Yes, ma'am.
Oh, the video has been.
Oh, 15 minutes. Shucks. Thank you.